Aluminium extrusion is a process in which a billet in a container is forced under pressure through an aperture of a die. Welcome to the exploration of aluminium extrusion surface defects, particularly in soft and medium-strength aluminium alloys, including 6060 and 6063. Aluminium profiles can exhibit various defects due to their manufacturing process. Surface defects are chiefly categorized based on their origin: extrusion press-related, metallurgical-related, and mechanically determined defects. Let's start with extrusion press-related defects. First up is the pickups. These are small particles of aluminium and oxides that tear away from the surface and settle back on it, forming comma-like shapes in the direction of extrusion. Next, we have die lines. These are grooves running parallel to the extrusion direction, often appearing where particles adhere due to the pickup's defect. Another defect is bearing streaks, which appear as light or dark streaks caused by abrupt changes in die bearing lengths. Variations in bearing lengths at the junction points must be properly blended to prevent streaking. We also see chamber and web markings, which are streaks that occur at profile cross-section junctions, showing various structural differences in the strand surface. Longitudinal extrusion seam streaks are narrow lines running in the extrusion direction, often lighter or darker based on lighting, indicative of unavoidable process-related marks. The transverse weld defect reveals issues from trapped oxides during billet welding, resulting in parabolically shaped defects due to poor welds. Another critical defect is the back-end defect, cone-shaped and caused by contaminants accumulating in front of the extrusion pad, leading to separation at the rear of the extrusion. Moving on, we have speed cracks, which manifest as transverse surface cracks and can even resemble a fir tree in severe cases, appearing mainly at high temperature zones. Next are blisters, which are air bubbles that may appear in lines or irregular patterns along the extrusion, sometimes referred to as blowholes once ruptured. Surface waviness can affect the strand length, manifesting as uneven surfaces across the profile, marking fluctuations in quality. We also encounter chatter marks, which are regularly spaced surface marks transverse to the extrusion direction, resulting from vibrations during fabrication. A stop mark appears as a circular ring indicating the area of the transverse seam, notably in billet-to-billet extrusion processes. Finally, we have snap marks, characterized by rings with cutouts across the extrusion, caused by abrupt changes in parameters during the extrusion process. Lastly, a broken die can distort the desired cross-section of the extrusion if portions of the die are missing or misaligned, leading to serious quality issues. In summary, understanding these surface defects is crucial for ensuring the quality of aluminium extrusions. Regular checks and maintenance of equipment, along with process control, are critical to minimize these defects. Thank you for joining us. If you have any questions or want to learn more about aluminium extrusions, feel free to leave a comment below.